Hello everyone, this is Bilal and I welcome you all in our course that is Building Planning and Drawing using the AutoCAD. Okay, so in yesterday's class or last class we have discussed about the building planning. So we have taken the two exercises in the last class. That is, one is a small two rooms plan. That is only the plan is there. So we have seen this one using the coordinate system, also using the tools. Also we have seen that one. Okay, and one more exercise we have started that one. That exercise is the which is having a building plan, elevation and section we need to draw. So in last video we have completed the building plan. Here you can see this one, using the line command, using the offset command, in the edit commands, tool commands and everything. We have done this one. This is our basic presentation drawing which we need to minimally will give to the site. Okay, so which includes the walls, which includes the doors and windows, which includes the projections, that is plinth projections, slab projections and the chajja projections, and it includes all the details of the room sizes. Okay, and it the hatches also we need to show. If it is a BBM or if it is a stone masonry, depending upon that one we need to hash that one, or it is a concrete wall, then we need to show concrete. If it is columns are there, then we need to show the columns also. This is the basic presenting drawing which we need to give with these minimum details on the side. Rather than that, we need to add like furniture layouts, we can add that one, plumbing, this one, and we can add all these things. Okay, so we'll go with the next one, the next part of this drawing. So after the plan we need to do the elevations. Okay, so the position of the elevation, the as per the IS standards, the position of the elevation will always above the level, above the plan. Okay, so above the plan there is a elevation, and after that at the right side we are providing the sections, and below the section we can provide the site plan if it is there, or we can provide the schedule of openings also. Okay, most of the cases we are providing the site plan, then we can provide the schedule of opening, FAR ratios, all that things we are going to provide that one. Okay, so before starting the elevation, so what all things we need to keep in our mind, that is very important. Okay, the first thing is we need to find the levels of the different grounds. Okay, so we need to understand that one in the elevation. So what elevation we are showing here? So we can show the front elevations also, we can show the side elevations also. Okay, but in our this one we are, most of the cases we are showing different elevations, or which is which elevation is facing to the road, that elevation we need to show. Okay, so here we can consider this one as a front. In the front side of the building we are considering the road, so this front elevation we are showing here. Okay, in the elevation. So while doing the elevation, first we need to understand what is the level of the ground, what is the type of the ground, whether it is a slopy ground, whether it is a straight ground, whether having any objects over there, any undulations are there, that we need to identify that one. Okay, so in this example we are considering a straight ground, a plain ground, which is having a very minimum undulations. Okay, so the first step I'm going to draw here a ground line. I just draw a ground line here. So this is our ground line. Okay, I just write here a ground line. I will just write here. Okay, so this is ground level. I just okay, so this is our ground level. So first I need to draw the ground level. Okay, so once we draw the ground level, next we need to identify the different levels of the structure. So how many levels of the structures are there? The first one is the ground level. Okay, and below the ground level, that is the substructure, and above the ground level, that is a superstructure, and at the top, that is a roof. Okay, always you just remember, in the front elevation we are not showing any substructure. What is meant by front elevation? If you stand in front of the any structure, whatever the elevation you will show, you will see, that we call as front elevation. So if you stand in front of any structure, if you see the elevation, or you can take any house, you just see the elevation, you will not see the foundation that is below the ground, it will not visible. So always you just imagine that. So we are standing in front of the building, that is here, we are standing over here, and we are seeing this particular structure, and the whatever the foundation will be there, that is the below ground, that is not visible. Only the thing is what will visible here, if you're standing in front of the building here, so these steps will be visible, correct, this veranda visible, okay, this wall visible, this window visible, this window, and this corners, and this corners. Main door is also not visible because we are seeing in this direction, correct. So I just draw so that we can easily identify that one. So which direction we are standing. So if it is we are standing in this direction, so we are facing like this. So if you stand here, the steps, this window is visible, this door will not visible because in the side elevation it is visible, not in the front. And this wall, this window, again this side wall will not visible, only here this corner line visible, this window and this wall and this corner and this corner, and this slab projections, this, correct, and this surges. So these things will be visible in the front elevation, correct. So next, so first, the first step of doing the elevation is, first we need to identify the levels. So first level is ground level. So below the ground level, no need to show that one. The first level is ground level. After the ground level, what level will come? After the ground level, the plinth level will come. Okay. So what is the height of the plinth? So here you can see this one, this plinth, whatever we have shown, that plinth level we need to show. Okay. So after the plinth level, we need to show the sill level. Okay. After that, what is the sill level? Sill level is the bottom level of the window. Bottom level of the window. After the sill level, the next we need to show the lintel. Okay. We need to show the lintel level. Next we need to show the slab level, and next we need to show the parapet level. So these are the different levels. So we need to show that one. Okay. So what is the size? What is the height of that levels? Okay, I just write it here. Front elevation. First one is ground level, that is at 0.0. Next one is plinth level, that is what we have taken here. Here you can see this one. Okay, plinth width 0.45, and what is the height of the plinth? So we can, as per the standard things, we can consider the plinth height as 0.45 meter. Okay, width also we can considering the 0.45, and height also we can consider the 0.45. The plinth height will be depends upon the road level. The plinth height is depends upon the water like what is the water table, at depending upon the water table also, and depending upon the road height also, we are considering the plinth level. Okay, most of the cases from the ground or from the road level, we are considering 0.44 meter height of the plinth. Sometimes it will goes high also, sometimes it goes less also. Don't go less than 0.45 meter. If you go less than 4.5 meter, then in the rainy season there is a chances of dampness of the floor. Okay, so most of the cases minimum height we just consider, that is 0.45 meter, that is the plinth height. So next one, sill level. So sill level will differ from the windows to windows, correct. So if you are considering the living room window, if the size of the living room or depth of the room window is more, if you compare with the bedroom, if you compare with the kitchen, okay, kitchen window height will be less because the kitchen top will become, so for that purpose the height of the kitchen window will be less. Bedroom height is different, living room is different. But in our case, in this particular drawing, so what we considering here, all the windows, here you can see this one, all the windows are 1.5 meter by 1.2 meters. So we are considering 1.2 meters. So what is the sill level? We need to calculate that one. So 1.5 meter is the width of the window, and 1.2 meter is the height of the window. Okay, so how to calculate the sill level? So total height is how much? 2.1 meter. Total height of the lintel. From the bottom of the lintel we need to calculate. From the floor level to the bottom of the lintel, that is 2.1 meter. That is already given in the question. From the floor level to the bottom of the window, that is 2.1 meter, and we are considering from 2.1 meter minus 1.2 meter is equal to 2.1 minus 1.2, so that is 0.9 meter. 0.9 is the our sill level. Okay, so this is in this example all the levels are same. So if it is a living room window, sometimes it will be changed, most of the cases it will be changed, and we can calculate for the different window level, we can calculate the different sill levels. Okay, so for the first one is the ground level, next one is plinth level, next one is sill level, and next one is lintel level. Lintel level is how much? 2.1 meter. This is the bottom of the lintel, from the floor to the bottom of the lintel, 2.1 meter. Next, slab level, that is also bottom of the slab, that is 3 meter. Next, parapet level. What is mean by parapet level here? So above the slab, a small height of masonry wall we are constructed, so that to avoid the accidents and all, and so that the whatever the rainwater will be there, it will not fall, it will not directly drain off through the walls. For that purpose we are providing the parapet wall, and safety purpose also we are providing the parapet wall. So 1 meter we are considering the parapet height, so that is 4 meter, correct? I just write here height of the parapet, height of the parapet 1 meter. So I think is it clearly visible? Okay, height of the parapet we can consider 1 meter. Okay, these are the ground levels. So now first we need to mark, the levels. So which is the first level? Ground level, 0 0. What is the next level? Next level is plinth level, that is 0.45. So I just take the offset command, press enter, 0.45, press enter. I just mark the next level. Okay, I just write here, this is a ground level. Okay, next, after the ground level, plinth level, I just write plinth. Okay, after the plinth, what is the next level? That is sea level, 0.9 meter offset. From the plinth it is 0.9. Okay, 0.9. Okay, I just write sill, then offset. After the sill, lintel level, that is 2.1 meter. 2.1 meter is from plinth only. Offset 2.1 meter from the plinth only, or from the floor only. Okay, this is lintel. Next, slab. Next one is slab level, that is 3 meter. that is from the plinth level only. Offset 3 meter. Let's enter. I just give you 3 meter. Copy. Slab. Next, parapet level 4 meter. That is from also plinth only. So every distance we are giving from the plinth only. Parapet. Okay, so we have marked the different levels: plinth, plinth level, sill level, inter-level, slab level, and bottom level. Sorry, parapet level. Okay, so once we mark this one, next step is we need to project the elevations. Okay, we are considering here the plan at the top and section here, but some architects the plan will be plan at the bottom, elevation at the top, and section at the right side. This is this format we are considering, but some architects will change this one. They will not follow the same things. Okay, so most of the cases this one will be used. Some architects will change, so there is no rules. Some rules will be there to do like this only. We can change that one. Some architects below that one, okay, top they will do the plan, and below that one they will do the elevation. Why? They to project these things, to project this elevation, it will be get easy. Okay, so first ground level, zero level. Next one, what we need to find? We need to find the plinth. So you just identify where is the plinth here. This is your plinth corner, this is your plinth corner, this is your plinth corner, this is your plinth corner. All the plinth corner you just project first. So I just go to the projection line or construction line, click here. I just click on the projection here in the upper direction. 1, press enter. Next, this corner or the corners we need to project. Next, plinth corner, okay, not of all corners. We are showing the plinth line here. Corner, this project, and this corner, okay, the same thing one, and this corner. Okay, so we had projected here. So extra, just with delete that one. So this is our ground and this is our plinth. So we have projected the plinth. So I just delete this one. So this is our plinth. So here you can see this one, ground to plinth. We have projected this 1, 2, 3, 4. 4 corners will be visible. 1, 2, 3, 4. Okay. So next, above the plinth there is a sill. Sill corners. Sill in the sense wall corners. 1, and here there is no wall. So second, and here one third, and here one is fourth. Again I go to the construction line. I just selected this one. I just project this line. 1, next 2, next 3, and 4. Okay, now you just join this one. So this wall from the plinth up to the which height it will go? This wall from the plinth up to the bottom of the slab, the same wall will move. Okay, above the parapet sometimes it will be changed. Okay, it will be sometimes it will provided on the projection also, sometimes it will provided on the above the wall also, and thickness of the wall also will be changed. But here from the plane to the bottom of the slab there is no changes in the thickness, it will go same. So the same thing we need to do. Okay, so I just trim whatever the extra part will be there. I don't want this. So in the plinth I don't want the wall. So if I see in front of this one, I just see this one. Okay, I just deleted. Okay, this is our parapet. Okay, to separate this one, just trim this one so that you can easily identify the things. Okay, I just make it as dotted so that clear. So here this is also we don't want. Okay, this is our front elevation. So we mark the plinth level, we mark the sill level, we mark the lintel bottom level, we mark the slab bottom level, we mark the parapet level. Okay, so next now you just see you just stand in front here and just see what is visible from this corner. You just start. What is visible? Steps, then veranda, then this wall, then window, then veranda. Okay, we'll start from here. We are using steps. Steps from where it is starting? From this wall line it is starting. Okay, this is our steps from here. From here it is starting 0.15. As I told you, the riser in the elevation, riser will be visible. In the plan, threads will be visible. So riser 0.15 we need to take, and thread we need to take 0.3. Thread 0.15 riser and thread 0.3 and 0.15. Okay, so this is our steps. From here it will be visible. Next, our veranda, and after the veranda our this wall will come. So which is that wall? Okay, this wall. This is our veranda. From here this wall will come, and we just see this one. Okay, veranda will over here. Where the veranda will over? The veranda will end here. That line we need to show. Or this okay. Next, this wall. This wall I have shown. This wall, this corner. After that, this window. This window will come. Just project this window and I just mark there 1 and 2. So here it will come. Okay, and what level? From the lintel bottom to the sill level the window will come. Remaining I just trim. Okay, so I projected the window. So one more window will come here. This is end of the corner wall. This is the corner wall, and one more window will come. I just showed that window. I just project 1, 2. Okay, I trim 2, 3, 4, 5. Okay, okay. So this is our, from here we get the steps. The steps we just write over here and will come here. We can considering this is as a railings which is provided here, and here our door is there. Here window, this is our window. Okay, this is our lintel level. So okay, and what will else will be visible here? Next, slab. So we just provide the lintel level here. it will not visible. I just show you what is the thickness of the lintel. I just write here. Thickness of lintel 0.15 meter. Thickness of slab 0.125 meter. Okay, these are the standard thicknesses which we are providing for the residential buildings. For the other buildings it will varies, and the thickness of the lintel also depends upon the width of the window. Okay, but width of the window is smaller here, that is 1.5 meters, so no issue. 0.15 meter is enough. Just go to the drawing. So this is our window, this is our slab. Okay, what is this? This is slab bottom offset. Slab thickness is 0.125. Press enter, and above that one we just provided the 1 meter height. Okay, so just delete this one, the level whatever we have provided, that is not correct. I just go to the offset command, 1 meter from the top of the slab. We have considered the from the bottom of the slab, so we need to consider from the top of the slab, it is 1 meter. Okay, so just delete this one. So this is our, and here again what will be visible? Slab projection 1, 2 and 3. This projection we need to show. So here what is our projection? What is our slab projection? I just check from this wall, the projection is 0.45. Okay, so we'll draw the slab projection 0.45. Press enter. Thickness is 0.125. Press enter. 0.45. Enter. And here also it will be visible 0.45. Only this line we need to show. That's it. 0.45. And thickness is 0.125. Press enter, and again 0.45. Press enter. So I just trim this one so that it will look. This will not trim because here it is a wall. Okay, so this is how our front elevation will looks. Now you can give the design to this. So we can give the different designs for the elevations. We can give the designs, all that things. Okay, so window will be there. So window I just offset 0.15. I just give the not 0.15 offset 0.1. that is the thickness of the window frame I'm considering, and I'm doing this one. Same. Press enter. Okay, so like this I'm considering the window here. This is our railings. Okay, I just give offset 0.1, that is the railing thickness. 1 meter. Okay, we can consider it, or we can evenly divide this one also, no issue. We can keep it as this only. We can do any other designs over here also. You can do the designs over here randomly. I can consider. Okay, so like this we need to give one more window we have missed. This window we have missed, this one. The here one window will come, right? So again we just project this one, go to the construction line, we just give the projection one. It will go wrong. Go to the projection line 1 2. What is the lintel level here? So this is our lintel level. Okay, this is our sill level. This is how our window will look. I just copy this one and I just paste over there. This is how we need to do the front elevation. So next, once we do that one, so we need to just move this one, show the dimensions. All the dimensions we need to show here. So in the front elevation, how it will look, we need to show that one. What are the in the elevation it is coming, we need to show that one. If you want to do, you can do the designs over here, correct? Whatever the designs, if you want, you can do the designs. I just give one small enter here, and here we can do this one as a railings, offset 0.1. Like this we can give the designs. I just use the array command. I just for understanding I'm giving this one. So depending upon the architect to architect and requirement of the client, and as per the we can use a circle also. Correct, like this we can give the like this we can give the different design for this one, and here also you can give something. Okay, so next we need to show the dimensions. Height of the plinth. Next, sill height we don't need to show, just show the lintel bottom 2 point. Okay, sorry, it is slab bottom, it is coming 2.98. our slab bottom is 3 meter, right? Why it is coming 2.98? we just check. Okay, 3 meter. So before that one we need to show the lintel height also, we need to show. Okay, so I just show here. .1 and slab bottom from the floor level I just show here, or I can show that side also. Thickness of the slab 0.125, it is 125, right? Dim style I just go modify text height I just changed so that it will be visible properly, and primary units I just keep it as 0.125. okay, close, correct. And parapet height, this is our parapet height. One meter. So like this we need to do the front elevation. Okay, so this dimension, showing this dimension is very important. All the dimensions should be properly shown so that it will get the idea about this one. Clear? So this is how we need to do the front elevation. And in the elevation you can do whatever the designs. In the elevation the important thing is these levels. These levels are the very important part. Okay, so if you provide these levels at proper levels, so that the whatever the contractors will be there, whatever the clients will be there, architects, everyone, we can, those who are working in this side, they can easily identify these levels. So elevation, in the elevation the design and the levels are the important part. Okay, so as a in the presenting drawing or in presentation drawing, so this much should be minimally we need to show in the working drawings: the dimensions, the levels, and the front design. Or if you stand in front of this one, whatever the things will be seen, you just need to show here. Okay, so I just write here, what is this? Front. This is our front elevation. Okay, this is how we need to do the front elevation. Now we just see the how to draw the section. Okay, so to draw the section, so first we need to identify that one where the section line is passing. So what is meant by the section? Section is nothing but it is a cross section of this void. Okay, the building is the whatever the section we have, this is a cross section of this line, the cross section of this wall, the cross section of this door, this wall, and this wall. So this is door, and this is a continuous wall, but here the door opening is coming. That door opening is only the from the plinth level to the lintel level, that's it. Okay, above that one, above the lintel level there is a wall, and below the plinth level there is also a foundation of the wall. Okay, so okay, first thing we need to identify then where this section is line is passed. So this section line, wherever this section line is passed, in that section we need to show that one. Okay, and one more thing, this section line will be passed through the most of the critical cases. Okay, here we are just simply passed over here, but most of the cases where the most of the information will get covered, in that places we are providing the sections. Okay, so here we can provide this one also. Okay, or else we can provide the section like this also. I can show you. Like this also we can provide the section line, correct. So it is passing one wall, it is cutting another wall, it is cutting one more wall, it is cutting this wall and this one. So like this also we can cut the sections. Okay, let's we take the first one only. Okay, so this is our section line. So first thing we need to identify that one, that section line is what is that. So what is how many number of walls it is cutting. Okay, so once you cut this one from here in the cross section, if you cut this building and if you stand here, what all things will be visible, that we need to show. For example, we are standing here, we are cutting this section and we are just seeing this one in this direction. So if you cut this wall, you will see this one, and if you come here, you just see this background wall also. Okay, so this door cutting, and if you come here, so this dotted line will also be just visible. Okay, we are considering this is as a opening. Okay, if it is a opening, then what happened, directly we can see this window. If you come here, if you cut this one, if you stand here, if it is, we can consider this as an opening, then we can see this window. Okay, then this wall, then this door also will see, correct? If you stand here, you can see this door also, and this wall, and okay, this much we need to see. Okay, so what, this wall section we need to show, this wall section with door we need to show, and this window we need to show, this wall section, this door, and this wall section. These things are visible in the cross section. That all things we need to show, correct? So how to start the cross section? So to start the cross section, the first thing is we need to draw the ground line. So whatever this ground line will be there, the same ground line I just project, so that it will be easy to draw that one. So I projected the draw line. Okay, so the next step is we need to identify the levels. How we are doing in the front elevation, the same things we need to think. Identify the levels. What are the levels? So in the cross section, not only the superstructure and the roof, we need to identify the levels of the ground also. Below the ground also, what all things will be there, that things also we need to identify. Okay, so I just open the text. I just write here what all things will come in here. Okay, section at x-axis, correct? So at x-axis we are showing the section. So from below the ground, below the ground of thickness okay, below the ground we need to do the PCC, plain cement concrete, of thickness 0.1 meter. Okay, so after the excavation, okay, after the marking on the ground, next step is excavation. Why the procedure of the construction? After the excavation, after the any excavation, first step we need to do is we need to provide the plain cement concrete. Any structure you take, whichever will start from the soil, subsoil, or in the soil, we need to provide the PCC. Without PCC we can't do any structure. Okay, so always first step is after the excavation on the soil, we need to provide the PCC, or we need to provide the soiling, or we need to provide the this one, but always we need to provide the PCC. Why we need to provide the PCC? Because to sustain the soil pressure also, at the same time, okay, it will not take that much of soil pressure, so at the same time, if any reinforcement will be provided in the concrete, to avoid the rusting of the concrete also, the rusting of the bar also, we are providing the PCC, and to avoid the dampness, that is the important, and to avoid the dampness we need providing the PCC over there. Okay, so first step we need to do is we need to provide the PCC. Okay, so after the excavation we have provided the PCC. So about the PCC, this is we are considering this one as a load bearing structure. Okay, we are considering this one as a load bearing structure. So two-step stone masonry we are providing. Okay, so we are providing the two-step stone masonry, and above the two steps we are providing the plinth, and above the plinth superstructure or our wall, and above the wall there is a lintel, and above the lintel again wall, and again slab, and again parapet. That is our whole cross section. Okay, so we are considering two-step stone masonry, two-step stone masonry. First step of size, first step of size, 0.8 meter by 0.5 meter. Second step of size 0.6 by 0.5 meter, and plinth of size, already we have seen that one, 0.45 meter, size 0.45 meter. Okay, so here in this section, below the ground level of PCC 0.1 meter we just take. Next, two step stone masonry. The first step is 0.8 by 0.5 meter, that is 0.8 is the width and 0.5 is the depth, and second step is 0.6 is the width and 0.5 is the depth, and the third one is plinth size is 0.45 meter. Depth depends upon this one. Okay, so now I just go to the AutoCAD. Okay, so here where we need to draw this section, or where we need to draw the foundation, below the wall, correct? So which walls? 1 2 3 4, whichever this cross section line is passing, that sections of the walls we need to draw. Okay, so how to draw that one? The first step is we need to extend the, or we need to draw the ground level. Next step is we need to mark the center lines of the wall. We need to mark the center line of the wall. So this center line of the wall, this center line of the wall, this center line of the wall, this center line of the wall. I just mark the center line first on the plan, then this line I just copy over here, and then easily I can do that. Okay, I just go to the section line. So how to mark the center line? I just go to the line, I just extend this line so that I can easily, one wall, this is our second wall, just extend this one, so can easily take the center line. Third wall, and this one also, third wall, and the fourth wall. Okay, now I just take the section line, I just mark the center. This triangle shows the center line. Again I just go to this triangle, shows the center line, 1 2, third wall, and the fourth wall. Okay, so these are the center line of this wall. Okay, I just copy this one, just see it properly, just copy, and I just paste on the ground line. Okay, I just pasted, and this line I just deleted. Okay, so these are the, so here 1 2 3 4 wall it is crossing, 1 2 3 4 walls are crossing. So these are the center line of our walls. These are the center line of our walls. Okay, why we require the center line of the walls, that I will tell you also. Okay, so next step is we need to draw the foundation first. After the foundation, plinth, above the plinth lintel, then slab, then parapet. Okay, so what is the depth of the foundation? How much we need to take the depth of the foundation? So what we are seeing here is we are considering two steps stone masonry. So already 0.5 and 0.5. Okay, 0.5 and 0.5, it is 1 meter, plus 0.1, 1.1 meter. Already 1.1 meter is the it will consider here. So minimum depth we need to provide this much, correct? Minimum depth we need to provide this much. But as per the technical, okay, as per the engineering, how to identify the depth of the foundation? So to identify the depth of the foundation will be depends upon the soil bearing capacity of the soil. What is the SBC of the soil? Depending upon that one, how much load it will be transferred to the soil. Depending upon that one, we need to go for the excavation of the, or depth of the foundation. So normally or minimum as per the standard, we need to go 1.5 meter or up to the hard strata, we need to go for the excavation. 1.5 meter or up to the hard strata, we need to go that one. So minimum we need to go for the excavation is 1.5 meter. So I was just considering 1.5 meter. Offset I just take, enter 1.5 meter. So minimum depth of the foundation is 1.5 meter. I just delete this one. Okay, correct, fine. Next, what is the width? What is the width of the excavation? So what is the width of the excavation? It is mentioned here. The first step masonry is, that is 0.8 meter. This is the larger one. This is 0.6, this is 0.45. So this is the first step, that is the larger one, 0.8 meters. So that is the size of the stone. 0.8 is the width of the stone masonry. Okay, so what is the excavation width? Exactly, if you take 0.8 meter, then it is very difficult to construct that one. There is no projection. If it not projection will be there, then it is very difficult to do the mason work for the labor. So we can consider it 1 meter. So 0.1 or 100 mm 100 mm extra offsets we are taking, so that it will be easy to do the masonry work. Okay, so I am considering width. So depth of the foundation we have marked, width of the foundation, offset 1 meter we are taking, width of the foundation, that is 0.5, 0.5 and 0.5. correct. I just trim the extra part. Let's trim this one. We don't want all that things. So depth of the foundation is 1.5 and width of the foundation is 1 meter. Correct. So once the excavation is done, this much excavation we have done. Once the excavation is done, next step is we need to provide the PCC. We just go to the offset. What is the PCC thickness? 0.1. It is already mentioned here, 0.1. We just provided the, after doing the excavation, we have provided the PCC. Okay, after the PCC, we need to provide one step stone masonry, second step stone masonry, then plinth will be continue till this level, plinth level. Okay, so next, second step of the side stone masonry. First step of side stone, 0.8 meter is the width, 0.5 meter is the height. Okay, so I just go to the AutoCAD, offset 0.8 meter is the width. So this is the center line, 0.4, 0.4. 0.4, press enter, 0.4, 0.4. And what is the height? Height is 0.5 from the PCC level. Correct. So now just trim the extra parts. Okay. Whatever the extra part will be there, we just trim. The first side stone masonry we have constructed, we have drawn. Next, second step. What is the size of the second step? Second step's stone size, that is 0.6 by 0.5. So I just draw this one. Offset, press enter. 0.6 is the center, 0.3, 0.3. Total is 0.6, 0.3, 0.3. And offset, what is the height? 0.5. So I just trim that one, extra part I just trim. Okay, next, plinth. So what is this plinth level? This is our plinth level. So up to this plinth level we need to take the plinth height. Okay, so height is depending upon whatever the difference amount will come, according to that one we need to take the height. Okay, what up to the plinth level height we need to take, but the width we need to take. What is the width? The width of the plinth we need to take 0.45 meter. Correct. We need to take the width of the, this one is 0.45 meter. So okay, from the right side and from the left side. So just go to the offset command, press enter. From the right side, if you 0.45 divided by 2, that is 0.225. Press enter. Okay, now I just trim this one, extra part I just trim. Okay, so up to which level it is goes? Up to the plinth level. I just project this one, the string. This is our plinth level, correct? And this also extra part I just trim. This is our plinth level. So above the plinth, so once we construct the this is 0.45 the plinth top, but we are providing the PCC over here also. We are also providing the PCC over flooring here also, that I will show you later. Okay, above the plinth there is a superstructure. So what is the thickness of the superstructure or thickness of the wall? That is 0.23, correct? So we need to draw that one, 0.23, that is offset. Press enter. 0.115, 1 2, and I will just trim the extra part. Okay, so now next lintel level. I just show, slab level I just show. This is slab level, this is our projection. Okay, I just trim. So we got these levels. Okay, so next sill level also we need to show. Sill level also. Okay, we get this one. So above that one we don't want this. This is our top. So okay, next one is window. This is our plane. Okay, so we have drawn the now we don't want the center line also. I just deleted the center line. So our PCC, first step, second step plinth, and above the plinth superstructure or the wall. Okay, so here the window. So this is our sill level and this is our lintel bottom level. Above that one lintel we need to provide. I just offset, press enter. What is the thickness of the lintel? 0.15. I need to provide the lintel over here. After that slab and the further parapet. So and projection of the lintel also we need to show here, correct? What is the projection of the lintel? Sorry, chhajja, not projection of the lintel, projection of the chhajja. Above at the level of the lintel we need to provide that one. Bottom of the level, bottom of the lintel we need to provide the chhajja. The projection of the chhajja is 0.6 meters. I just press enter. What is this thickness? So here I just do one thing. I just take a thickness at the projected end. I just take a thickness of the chhajja is 0.1, and at the lintel level I just take the thickness is 0.15. I just am providing here, you can see this one, I'm providing a slight slope here, so whatever the rainwater will come, it will be easily drain off. For that purpose I'm providing a slight slope here. Okay, then chhajja projection, slab projection, that is 0.45, press enter. 0.125, press enter, then parapet level. Okay, now we just see that one. Oh, okay, here we just see this one. The lines is crossing the first wall, second wall, third one, and fourth wall. For all the walls we need to draw, but here we did one small mistake here, that the section line is not crossing the window. If the section line is crossing the window, then only we need to draw the window here, but here it is not crossing the window, so no need to draw the window. So I just delete this one. I just use this sill level. I just delete the chhajja. But lintel, we need to keep the lintel over there. Why we need to keep the lintel over there? Because I am considering this is a load bearing structure. Okay, and in the load bearing structure the lintel should be provided throughout the walls. We need to provide the lintels. Always you just remember, in the load bearing structure throughout the walls, wherever the walls will be there, whether it is partition walls or whether it is main walls, we need to provide the lintels. So that's why I am showing the lintels here. And above the lintels there is a masonry, and above that one slab, then parapet work. Okay, so I just delete this extra parts. Okay, this is our lintel, this is our slab. Okay, so now I do just one thing here. So one section I have drawn. Okay, here I need to provide the PCC also. Above the at the plinth level, we need to provide the PCC also, so that to avoid the dampness in the floor. So what is the PCC level? I just take the offset, enter. The thickness of the PCC is 0.1. So as mentioned that one, here also we are taking the PCC 0.1, and here also we are taking the PCC 0.1. Press enter. So we have provided the PCC. So one wall is ready. So now what I do, we have 4 walls, 1 2 3 4. All the foundation is same for all the walls. Okay, everything will be almost same for all the walls. I just copy this wall and just paste all the 4 years. Shortcut, simply I just copy and paste over here, so that the work will get fast. How to copy this one? I just copy this one from this center to this center. So this wall center, I just, what is this wall center? This is our wall center, correct? I just check what is our wall center, 0.115. okay, this is our wall center. I just copy this one, I just select this, I just copy wall center, and I just paste here 1 2 3 and the 4. All the 4 walls will be there. So slab projection, I just delete. Whatever the extra part is required, we just draw that one. Whatever is not required, we just delete that one. Okay, first I just draw the plinth level. From here to here plinth, from here to here plinth, again this is plinth. Next I draw the lintel level. From here to here lintel. So no need to show here lintel, I just tell you, I just draw that one. Okay, so that you can easily understand that one, the different levels. Next one is slab. Or else I just extend, EX, extend, 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 extend. Okay, then projection, how much? 0.45, press enter. 0.125, press enter, and 0.45, enter, enter. I just delete the extra part. Whatever the center lines, I just delete this one. I just trim the extra parts. Okay, and okay, and here one more thing, the parapet. I will just come to the parapet. So here this is the parapet, this is the parapet. Always you just remember, so here it is cutting, this is the inner wall, this is the inner wall, this is the exterior wall, corner walls are the exterior walls, and middle walls are interior walls. So always you just remember, the parapet always we are providing at the exterior walls only, not in the interior walls. Only at the exterior walls we are providing the parapet. So only at the exterior wall only we need to show, on the interior wall we don't need to show. So I just delete this one. Now the parapet level, this is our parapet level, correct? So here I just delete this. So we have drawn this one section. See here how quickly we draw. Once one section if ready, then all the sections we need to draw. So now whatever these things visible, we need to draw this one. If we cut this one, only the walls. Okay, we have drawn only the walls. If we cut this one, here we need to show the door. So half door we need to show. So door is inside this one. What is the height of the door? Height of the door is 2.1 meter. I just check. Okay, 2.1 meter. So this is our door. I just a single line, you just show that one from here to here, so that you can easily identify that one. Here one door is there. I have shown the door. Or just next. So here there is a full opening. Okay, here there is full opening. or if it is considered as an opening, then if you cut this section and we can stand and we see here, so this window will be visible, correct? This window we need to draw here. So how to draw that one? We can directly project here also, but it is not exactly above that one. So just see the distance. What is the distance of the window from the corners? That is 1.05 from the left corner, and from the right corner 1.05. okay, so this is our wall. So from here I just take offset 1.05 from the right corner, from this wall and from this wall. And what is the height of the window? That is 1.2 meters. So remaining part I just trim. Clear? Next, this window visible. Next we cut this section, this door, and after that this wall. After that this door will be visible. If you see here, you can see here the door is visible, then this wall. What is distance? What is the length of the door? 1 meter, correct? Oh sorry, 0.9 meter. Is it 0.9 meter, 1 meter? I just check. So here we go. Door is 1 meter, right? So door width is 1 meter. Okay, and this one is 0.75. And why it is 0.9 here? Some mistakes we have done. This door I just check. This is 1. Okay, correct. This door I just check. 1 meter. This door, okay. We need to change this one. This we have made as a 0.9. Okay, because of this, see here the wall will ending here only, exactly here only it is ending. If you do point again 1 meter, then it will come here. Okay, so because of that only we just did 0.9 meter door. There is no issue. 0.9 meter and 1 meter door we are providing for the bedrooms. There is no issue. So how much door width is? 0.9 meter. So we need to show the door here. So I just go to the offset, width of the door I just provide 0.9, press enter. I just go to the trim command and I just trim this one. Okay, so here we no need to show the lintel, and again no need to show the lintel. Okay, and here this wall, simply the wall is there, nothing is there. I just do. Okay, so I just delete the lintel, no need to show that one. Below the lintel only there is a doors and the windows. Okay, so like this we need to show that one. Wall, the wall which is cutting the door, the backside window, the wall, next to the wall there is a door and there is a wall, correct? So this is how we need to show the section. Okay, so here again I just trim this one so that it will looks continuous. Okay, so this whatever this foundation is there, that is a continuous stone masonry. It is a continuous stone masonry. Okay, next, flooring. We have not shown the floors. Flooring above the PCC or above the PCC plinth level, the flooring will come. What is the thickness of the floor? We can consider including the bed, including the sand bed, and include the thickness of the floor. I just considering 0.1 meter. 0.1 meter is more only. I'm just considering. Normally it is in between 0.05 to 0.1. Okay, this is our flooring, and about the flooring here, lintel, slab bottom, sijja, and okay. So these all components we need to show. Okay, so we just check whether all the components cover wall, and this one door, and this opening, this stall, this one. Clear? So if it is a arch, for example, if it is arch, then we need to show a small arch over here. For example, I just show that one. Arch will start from lintel level, from here, like this. We need to show a arch here. If it is an arch, then we need to show the arch, and we can do this one if it is. So it is not mentioned that one whether it is an arch or whether it is a direct opening. Okay, whether it is movable things like this also we can show. Not mentioned, so I just delete this one. Okay, so next we have shown the plinth. So we have shown the foundation, next plinth, next about the plinth PCC, then wall, superstructure, and about that one parapet, and here also about the plinth and the floor and door, and all the things are shown. Now we need to identify the things. How to identify the things? Identify in the sense we need to hatch the things. Once you hatch the things, by hatching the things you will identify that one, what is this. Okay, so I just go to the hatch command, go to the hatch. Okay, so the first hatch is PCC. So PCC is made up of what? PCC is made up of concrete. So I go to the concrete hatch, I just click here and I just put on the PCC, but it is concrete is not showing. Okay, I just increase the scale, I click on this one, I just take 100, it is not coming. Concrete is not showing. Okay, here I can see this one, 0.01 and 0.005 if I show. Okay, 0.01. This is how we need to show this is how the concrete hatching looks, dot dot and small triangles. So which means that fine aggregate and the coarse aggregates. So this is the hatch of the concrete. Next we need to hatch the foundation. So go to the hatch command, foundation PCC. So I just said you that this is INSI 32 is for superstructure or burned brick masonry. Okay, or for the superstructure, and for the foundation we need to show INSI 33. So one straight line and one dotted line is for foundation and two straight lines for superstructure. Just click here, I just click here. Okay, scale to change. Okay, one, or I just change 0.5 is okay. Next, about the plinth, there is a PCC again that we called as DPC, dam proof course. About the plinth, there is a dam proof core DPC that is also made up of concrete. I just go to the concrete, I just add here, concrete ratio is 0.01. Okay, this much only just kept. Next, wall hatching, what I said, that is superstructure 1, 2 and 3. Just change this one and we just keep 1. Okay, next here lintel and slab is there. Lintel and slab is made up of what? Concrete only. I just show the concrete here, concrete here. Okay, I just change the scale. Clear? So this is our concrete, bed PCC, foundation DPC, and then superstructure, lintel, slab and the parapet. So similarly we'll hatch to the all these things. I'll just quickly hatch that one. so which is concrete, or here concrete, and here concrete, and here concrete. Just click on here concrete, here concrete. Okay, here I just put here, escape. Again go to the hatch, add pick point. You can do the pick point or directly point will take. Next, foundation I just take. Foundation is 33, one straight line and one dotted line. Next, again wall superstructure, go to the whole hatch, click here, 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 here. These are the superstructure. Okay. Next what else remaining? Hatch for the flooring and hatch for this gap, the gap between PCC or DPC, and the gap between DPC and the ground level. This is our ground level, right? So I just copy this one so that you can easily. This is our ground level. The distance, the depth, the distance between PCC and the distance between DPC and the ground level. Here we need to fill the sand, or we need to fill the soil. Okay, we need to fill the soil, and we need to compact that one. Once we fill the soil, we'll just compact. After the compaction, we need to put the DPC over this. I just goes to the hatch. I just fill this sand or soil. I just click the sand. Where is the sand? Okay, here it is, the sand. 1, 2, 3. Scale I just change. This is too much. Okay, next our flooring. For the flooring, I just give the solid. Go to the hatch. For the flooring, I just give the solid. Okay, so these are the components we have covered. So hatching you have done, all the components you had shown, everything we have done. Now we need to show the dimensions, and we need to give the namings for this one. Okay, I just show the dimensions here. I go to the dim style, modify, primary unit 0.0. I just take text, I just reduce 0.1. I just take, and arrow size also I just take 0.05 because the size is little. So here also you can easily use one. Okay, so first width of the PCC. Next, width of the first step, width of the second step, width of the plinth. It is 0.45. I just change this fractions. Once you change the fraction, you will get. Next, width of the wall. Okay, 1 seconds. Okay, so now depth. Depth of the PCC, depth of the first step, depth of the second step, depth of the plinth below ground level, depth of the plinth above ground level. Next, lintel, no need to show the lintel, directly we'll show the slab bottom. Okay, next thickness of this one, that is 0.125. okay, this is 0.125. why it is showing 0.13? Because the fractions we have taken only 0.00, that's why. If you change the fraction, it will come properly. Now thickness of the height. Okay, so all these things we need to show, everything, all the dimensions we have covered, correct? Next, so no need to show for all the walls, only one section we need to show. Now we need to show the what? We need to show the naming. We need to do the naming for the all the structure, all this one. I just go to the leader command for the naming. I just use the leader command, it will be easy. I just click on the leader command. Here it is asking specify the point. This is our point, first point. Okay, what is this? PCC, plain cement concrete, 1:4:8. okay, next, I just take as a 45°. This is one size stone masonry. First step, SSM, that is size stone masonry in CM in cement mortar 1:6. First step, size stone masonry in CM, that is CM in the sense cement mortar of in 1:6. Next, second step, SSM in CM 1:6. So for the stone masonry and for the brick masonry or for the masonry work, we are taking the cement mortar of ratio 1:6. 1:6 in the sense 1 part is cement and 6 part is the sand. Next, plinth, plinth of size stone masonry in CM 1:6. Next, what is this? DPSC. That is damp proof course. Damp proof course of 1:8. Okay, this ratio, this specification, what is mean this one? 1 is the cement, 4 is the sand, and 8 is the coarse aggregate, fine aggregate and coarse aggregate, fine aggregate, coarse. This will differ. Okay, this specification will differ. I am here taking this standard specification which is normally used in the residential buildings. Next, I am taking the BBM. Burnt brick masonry in CM 1:5. 1:5 I'm taking, because if it is a burned brick masonry, then the ratio of the cement just will be taken higher to give the more strength. Next, lintel RCC, that is reinforced cement concrete, RCC lintel in RCC lintel one is to 2:4. Okay, that is M15 or 1:3:6. Okay, no issue. Okay, next, RCC slab in 1:2:4. Next, parapet wall. Okay, so here you can see this one. This is a complete cross section of the particular building, correct? So in the presenting drawing, we need to show this complete cross sections. So what is that? We shown the ground level. After the ground level, below the ground level, whatever the structures will come, that also we have shown that one. So after that, above the ground level, the plinth will come. Above the plinth, DPC come. After the superstructure, lintel, slab, and the parapets, and all the sections. Once we cut the building in this cross section, whatever the things will be shown, that is doors, windows, everything we have shown here, correct? So we have shown the sand filling also. We have shown the flooring bed also, and we have shown the hatching to the all the elements of the structure, and we have shown the dimensions for the all the structures. Okay, and after that we give the specifications also. So this whatever you have naming you have given, this is called as specifications. Okay, in technical we call it as specification. We have given the specification also for this, correct? This is how. So I just write here below this one, section at x. This is our axis, right? So we have given section at x. I just do it smaller. Okay, so this is our section, correct? We have done all the hatching, everything. Okay, this is our complete building plan, or complete building plan, or complete building presenting plan. Okay, so these are the minimum things which should be there in the any plans. Okay, so as an engineer, as an architect, as a consultant, so these things should be there in our plans always, which is similar. These are the minimum things. This should be there in the plan. Okay, rather than that, you can give the other layouts and all. You can attach to the drawings. There is no issue, but minimum this much should be there in the plans. Okay, this is how you need to do the building plan, building elevations, and building section. This is how the procedure of doing the things. Okay, so this is the second example we have completed here. Okay, so we have seen this one, that is the load bearing structure, and it is only a ground floor also. So in the next example, we just see this one, RCC structure or RCC frame structure, and we see the multi-story also. We just see in the next example. Okay, hope you will understand the how to do the planning, how to do the draw the elevation, how to draw the section, and what are the technical things are there, technically how to, what are the standard sizes are there, what are the specifications are there. I hope everything you just understand this one. If you have any doubts, you just contact us, and you just have any doubts, you just repeatedly you just see the video, so that you will get the idea. Okay, so always one time, two times you just see the video, so you will get the perfect idea about that one. And if you feel any difficulty in the tools, just contact us, we just try to solve your things. Okay, so most of the cases, on the focusing on the tools, we are focusing on the planning, we are focusing on the technical building planning, building elevation, their procedure, their sections. Okay, so that will be the things. Okay, uh, thank you. Thank you so much. I will just finish this class here only, and we'll see you in the next class. Thank you.